In this video, we'll look at the Heathkit HW-101 Single Sideband amateur radio transceiver. I'll cover the history of the radio, its features and key design aspects, and go over the front and rear panel controls and connectors. We'll also take a look inside. I'll talk about the restoration of this particular unit and give a demonstration of the radio in use. Heathkit was a company that sold electronic devices in kit form from the late 1940s through the early 1990s. They were particularly known for their extensive and popular line of amateur radio equipment. Heathkit sold several series of amateur radio equipment at various price and feature points. They range from low-cost shortwave receivers and CW-only transmitters to the HW and SB series. The HW-101, offered from 1970 to 1983, was the most popular amateur radio model Heathkit ever sold, with probably more than 40,000 made. It was the successor to the HW-100, sold from 1968 to 1970. Very similar to the HW-100, it has slightly different front panel styling, a different tuning system, better sensitivity, and front panel switching of single sideband and CW filters, the latter being optional. Like the HW-100, it was a low-cost version of the more expensive SB-100 series of radios. It used the same printed circuit boards as the SB-101, but with a lower-cost chassis and cabinet, simpler VFO and tuning system, and slightly fewer controls. It sold for about $400 in 1970, equivalent to about $2,500 today. The last tube-type rig Heathkit made, it was replaced by the HW-104 in 1975, which was all solid state and was essentially a low-cost version of the then-current SB-104. However, it was still sold until 1983, as shown in this Canadian catalog from that year. Accessories for the HW-101 include the optional 400 Hz CW crystal filter, the HP23 series AC power supply, HP13 series mobile power supply, desk microphones like the HDP-121, and the matching HS1661 and HS24 speakers, and a mobile mount. Most SB series accessories also worked with the HW-101. The transceiver covers the 5 classic HF amateur radio bands, 80, 40, 20, 15, and 10 meters. The dial features vernier tuning with 35 revolutions over each 500 kHz band segment. It has a built-in 100 kHz crystal calibrator. The receiver boasts better than 0.3 microvolt sensitivity, single sideband selectivity of 2.1 kHz, and CW selectivity of 400 Hz with an optional filter. It has a calibrated S-meter, external speaker and headphone jacks, and audio output of 2 watts. The transmitter provides DC input power of 180 watts PEP on single sideband and 170 watts on CW at 50% duty cycle. The RF output is about 100 watts, 80 watts on 10 meters. It supports single sideband and CW with press-to-talk or Vox modes. There's an internal side tone for CW, and it requires a high impedance microphone input. There's support for connection to an external linear amplifier via an ALC input. The design uses a whopping 20 tubes, used as follows: 0A2 regulator, 6 HS6 RF amplifier, 6 HS6 first receiver mixer, 6 AU6 isolation amplifier, 6 AU6 first IF amplifier, 6 AU6 second IF amplifier, 6 BN8 product detector and AVC, 6 AU6 VFO amplifier, 6 CB6 second transmitter mixer, 6 CL6 driver, 6 EA8 speech amplifier and cathode follower, 6 EA8 first transmitter mixer, 6 EA8 second receiver mixer and relay amplifier, 6 EA8 CW side tone oscillator and amplifier, 6 GW8 audio amplifier and audio output, 12 AT7 heterodyne oscillator and cathode follower, 12 AT7 Vox amplifier and calibrator oscillator, 12 AU7 sideband oscillator, and 2 6146 final amplifiers. It also uses 6 germanium diodes, 9 silicon diodes, 1 xenon diode, and a field effect transistor in the VFO. It requires an external power supply. The power requirements, which are met by several models of Heathkit power supplies, are 700 to 850 volts DC at 250 milliamps, 300 volts DC at 150 milliamps, minus 115 volts DC at 10 milliamps, and 12 volt heater voltage at 4.76 amps. It weighs 17.5 pounds. Let's take a look at the front panel controls. The driver preselector knob peaks the RF amp and transmitter driver tune circuits. Mic CW level adjusts audio drive when in single sideband mode, and carrier output level when in tune or CW modes. A 1/4 inch phone jack allows connecting high impedance headphones. The mic input is for connection to a high impedance microphone with press to talk switch. The round knob is the final tune control, which is adjusted to peak the final amplifier tune circuits on transmit. The lever arm is the final load control, which adjusts the impedance matching to the antenna. Both controls have some interaction and are adjusted for maximum power output whenever the frequency is changed. The mode switch selects upper sideband, lower sideband, or CW mode of operation. In the tune position, the final amplifier is turned on so the driver and final RF stages can be tuned. The band switch selects the operating frequency over one of 8 500 kHz ranges, starting from 3.5, 7, 14, 21, 28, 28.5, 29, and 29.5 MHz. The main tuning dial selects the VFO frequency over a range of 500 kHz. You add the dial reading to the base frequency of the band selected. The zero set button locks the dial scale when pressed and allows adjusting the dial against the crystal calibrator signal every 100 kHz. The function switch selects between press to talk or Vox modes, and in the cal position turns on the crystal calibrator. The filter lever selects between the single sideband or CW crystal filters. The CW filter is optional and is present on this unit. RF gain controls receiver sensitivity and is turned down if needed when receiving extremely strong signals. The meter switch selects the operating mode of the meter. In the ALC position, it acts as an S meter on receive and shows ALC on transmit. Relative power shows an uncalibrated indication of the RF output power. In the plate position, the meter shows the total cathode current going to the final output tubes. AF gain has the power switch and controls audio volume. Looking at the rear panel, CW key is a 1/4 inch phone jack for the Morse code key. 8 ohm is the external speaker connection. ALC is the automatic level control input used with an external linear amplifier. Spare is unused and available for future use or modifications. Ground is a lug for a ground connection. Power and accessory is an octal jack going to the external power supply. Antenna is for the external antenna connection. The connector was originally a phono jack. Like many units, this one has been converted to use the superior SO239 UHF connector. The hole on the right is used by the mobile mounting bracket. On the side are some rarely adjusted controls for Vox sensitivity, Vox delay, and Vox anti-trip. Also the S meter zero adjust and bias control for setting the final RF amplifier bias current. Let's take a look inside, but first a note on safety. While any AC operated equipment can be dangerous to work on, this unit operates on almost 1,000 volts DC and produces almost 200 watts of RF power, which can easily produce a lethal shock or serious burns. You need to exercise extreme caution when working on or testing it. Double check that the power supply is really turned off and unplugged when working on it. Even when powered down, it takes about a minute for the filter caps to discharge with no load, and much longer if the bleeder resistors were to become open. Be particularly careful if working on the unit when powered, such as when performing alignment or neutralization. Also, don't transmit or use tune mode without a dummy load or antenna, and don't transmit for more than a few seconds without properly adjusting the driver preselector and final tuning and load controls, or you risk damaging circuitry such as the expensive final tubes. Circuitry is on 10 printed circuit boards and assemblies as well as the chassis. It uses factory assembled wiring harnesses. It also features switch boards, circuit boards which have band switch wafers mounted on them to reduce the amount of wiring needed. On the top are 5 printed circuit boards. Clockwise from upper right, they are the audio circuit board, the bandpass circuit board, the IF circuit board, the modulator circuit board, and the RF driver circuit board. These circuit boards are also used on the SB-101 transceiver, helping reduce cost. A nice feature of the schematic is that the first digit of the component designation indicates which board the part is placed in. For example, R301 would be on the audio circuit board because all discrete components on that board start with 300. A large component on the audio circuit board is the PEC hybrid module. This is a phase shift circuit for the side tone oscillator. Toward the end of the HW-101 production, this part became discontinued, and Heathkit designed a small circuit board to replace the module when it was no longer available. A 1979 Heath bulletin said they still had a 3-year supply of them, so it's unclear if they actually had to use this board. It's shown in later versions of the manual. The VFO is contained in a shielded metal case. It has one tube on top and a field effect transistor inside, as well as the variable tuning cap. The vernier uses 2 Jackson reduction drives, one inside the shielded box and one in front of it. Inside the shielded high voltage cage are the 2 6146 final tubes, final tuning and loading caps, an inductor, and a transmit receive relay. A second relay is outside the cage. The dial and meter are lit by 2 pilot lamps. The driver preselector controls 2 variable caps linked using belts. The final tuning and loading caps use 2 concentric shafts, one of which uses another belt. Late versions of the HW-101 switched to using dial cords rather than belts. Several tubes have shields. Some of the front panel controls use point-to-point wiring that can be seen on the top, as well as some wires that interconnect the circuit boards. Underneath are 4 more circuit boards which correspond to wafers of the band switch. They're the crystal switchboard, heterodyne oscillator switchboard, driver plate switchboard, and driver grid switchboard. This central portion is shielded with a cover plate, which has holes to provide access to the inductors which need to be adjusted during alignment. There's a significant amount of point-to-point wiring under the chassis. 2 wiring harnesses are used, as well as some terminal strips. Some connections use coax cable. The 2 crystal filters are here. These are factory assembled and sealed, and the one on top is the optional CW filter. There are 5 controls mounted on the side for the Vox and other adjustments. Despite the use of printed circuit boards and factory assembled wiring harnesses, assembly of an HW-101 would have taken considerable time. The manual has over 200 pages of detailed instructions. A conservative estimate of assembly time might be 40 hours, not counting any possible troubleshooting. The manual recommends some initial resistance checks, followed by an initial test which includes checking some key voltages. Alignment requires a high impedance multimeter such as a VTVM and a dummy load. Much of the circuitry is crystal controlled, so it can be aligned without a signal generator. Transmitter alignment is easier with an oscilloscope or VTVM with an RF probe. Crystal calibrator alignment is ideally done with the aid of a shortwave receiver, which can receive an accurate frequency standard like station WWV. The manual has extensive troubleshooting information listing symptoms and possible causes. I bought this unit on eBay in February of 2016 from a Canadian seller I'd bought from before. It arrived very well packed, looked complete with only minor scratches, and was just a little dirty inside. It was sold as not working and for repair, but was said to be working. It had the optional CW filter, which is a big plus as they're not easy to obtain. It didn't come with a manual. I checked several sources for manuals and decided to order it from the official Heathkit. I was a little disappointed as the manual they supply is unbound and was quite an old version which did not have all the later circuit changes, pictorials, and updates. I ended up putting it in a 3-ring binder and printing quite a few pages from a newer manual I found on the internet. If you restore an HW-101, you'll also want to get the relevant Heathkit technical bulletins that address a number of later circuit modifications and solutions to common problems. Before I could get very far, a side project was to track down and obtain an HP23 power supply. I did that and have covered it in a separate YouTube video. I also obtained and restored a suitable microphone, the classic Astatic D104. I hope to cover it in a future YouTube video of its own. Before powering it up, I went through the entire assembly procedure in the manual to verify all steps were performed correctly with the right components. I measured all resistors and replaced those that were out of spec. I checked the diodes and tested the tubes with the tube tester. I checked the variable caps for shorts. I replaced the pilot lamps with number 47 type. These often have number 44 types installed in error or have burned out, which can damage the tubes. The belts were quite old and were slipping. I replaced them with new ones, as well as the rubber feet. For some reason, the unit had large feet on all 4 corners, so it was not sloped as it should be. Tubes V10 and V11 should be 6HS6, but a 6AU6 and 6AU6A are installed. This is a common substitution because the 6HS6 tubes are now hard to obtain and sell for about $40 each from tube suppliers. Some of the tube shields seemed to be on the wrong tubes, and there was one extra. I moved these around. I gave the unit a good cleaning, lubricated moving parts, and used contact cleaner on switches. I performed resistance checks as per the manual. There were a few loose wires on some of the switchboards that needed to be resoldered. It was missing the high voltage sticker on the back, so I made my own using a laser printer. I noticed that it was missing the coil cover that goes on the underside of the chassis. This was strange as it needs to be in place for proper operation. I couldn't think of any good reason it would be intentionally missing. I considered making one from aluminum, but I was fortunately able to find one on eBay from a parted out radio. It actually came from an SB series transceiver, but they used the same cover. It was now time to power it up slowly using a variac. I did so and saw the pilot lights come on. Then I saw smoke coming from the underside and quickly removed power. A resistor in that area looked burned. It may have been shorted to the cover plate, or maybe a lug of the band switch was shorted to the shield. I replaced the resistor and checked the position of the wiring components around the shield. Powering it up again, it seemed to be working reasonably well, at least on receive. I then measured the voltages as per the manual. I replaced all 4 electrolytic capacitors for good measure, as these were likely to fail at some point in the future. The AF gain control was pretty scratchy. I tried cleaning it, then opened it up and saw that the contacts were completely worn. I ordered and installed a replacement control with switch. The tuning dial was tending to slip. One of the 2 Jackson drives was slipping. The second inner Jackson drive was okay. I took apart the dial assembly and cleaned and lubed the drive with no improvement. Disassembling it, I could see it was worn, likely due to use for many years and possibly being used without lubrication. It had many metal particles inside. I tried to reassemble it with increased tension, but it still slipped. I was able to find a supplier of new Jackson drives in England. The shaft diameter of the new drive was a little smaller than original, and it was also longer. I filed down the shaft on the inner Jackson drive so it would fit inside the new one. Then I cut the longer shaft of the new Jackson drive. Reassembling it, it now works without slipping. It's a little stiff, but I'm hoping it may loosen up with use. On transmit, I now seem to be getting about 100 watts of output into a dummy load. I then went through the complete alignment procedure without any problems. One of the more complex steps is neutralizing, a process which adjusts a capacitor to compensate for the internal capacitance of the final output triodes. The original manual has a trial and error procedure which is quite tedious to follow. A later technical bulletin lists an alternate neutralizing procedure which involves removing the final screen and plate voltages and adjusts the transmitter for minimum output. While it requires unsoldering some wires, it's easy to do and similar to how the old 1920s vintage Nutridyne TRF receivers were neutralized. I followed this procedure. The ALC meter did not move on transmit in single sideband mode, although the output power seemed okay. I spent some time troubleshooting it and tracked it down to a wire connection that was never soldered to a terminal strip. After soldering it, I got proper operation of the ALC meter on transmit. I have to wonder if it ever worked in the 40+ years since it was built. Maybe it worked intermittently with the unsoldered wire still making a connection. Another problem I needed to resolve was that the S meter would drift below zero after a period of time. The service notes list this as most likely caused by one of 4 tubes being leaky. I went through the troubleshooting procedure to diagnose which tube was at fault and determined it was V3. My tube tester confirmed this. I have a replacement 6AU6 tube on order. To use the previously mentioned astatic microphone, I needed to obtain a suitable 2-pin Amphenol connector and wire it to the mic. Despite being in good cosmetic condition, this was one of the larger Heathkit restoration projects I've completed. There are always some Heathkits that have been little used, in some cases because the owner failed to successfully build them. Despite the problem with the unsoldered wire, it would appear that this radio was used quite heavily over the years, given that most of the tubes were changed from the originals and that the Jackson drive and volume control pod had worn out. I hope to use it for many more years to come. It may have been made later in the production run of the HW-101 series because it includes all of the later circuit changes. Or the owner may have made these changes later. I don't have the matching HS1661 speaker, but I do have this SB600 from the SB series, which was also considered a matching speaker and can be used to house the power supply. Let's see a short demonstration of the unit operating. First, receiving. Make sure you've connected the power supply, a speaker, and antenna. Set the power supply to the 300 volt setting if applicable, and turn the radio on. It takes a few seconds to warm up. To be completely stable can take as long as 30 minutes. So we set the desired band and the mode to either CW, upper sideband, or lower sideband as desired. AF gain adjusts the volume, and RF gain is normally full, but can be turned down for extremely strong stations that might be overloading the receiver. We adjust the driver pre-selector for the maximum signal or noise, then adjust the tuning dial to the desired frequency. Here I'm on 7 megahertz, and the dial reads about 100, so the frequency is 7.1 megahertz. If you change the frequency significantly, you need to again readjust the driver pre-selector for a peak. The meter is normally in the ALC position where it indicates signal strength in standard S units. The filter can be set to the single sideband position for single sideband signals, or if desired to the narrower CW position. Because the CW filter has a narrow 400 Hz bandwidth, the signal can only be heard over a narrow frequency range. Here we can hear a number of CW signals close together in frequency. If we switch the filter to CW mode, then we will more clearly hear just one signal. For maximum accuracy around the operating frequency, you should calibrate the dial using the crystal calibrator. This is done by setting the function switch to cal and then adjusting the dial to the nearest 100 kilohertz frequency multiple. The 100 kilohertz calibrator signal should be heard. If the 0-beat frequency of the signal does not line up with the correct dial position, you can press the 0 set button and turn the dial until you get a 0 beat at the 100 kilohertz multiple dial reading, then release it. To transmit, you need to first tune up the transmitter. Make sure an antenna, or here a dummy load, is connected, as well as a code key and or a microphone. Turn the mic CW level control fully counterclockwise. Set the final tuning control to the position corresponding to the band in use, here 7 megahertz, and the load lever to near the 50 ohm position. Set the desired band and frequency and set the meter switch to the relative power position. Turn mode to tune and turn the mic CW level up until the meter starts to move. Then adjust the driver pre-selector and the final tune knob and load lever for maximum indication on the meter. If you have a power meter or SWR meter like this Heathkit HM-102, I find this is easier to read when adjusting for maximum power because the meter is larger. Now turn the mic CW level up until the meter no longer increases with the dial rotation. And then again adjust the driver pre-selector, final tune, and final load controls. If the meter is moved to the plate position, then when tuning it should show a reading of about 40, indicating a plate current of 250 milliamps. When the mic CW level is turned down to minimum, it should be at the mark indicating 50 milliamps. Now the radio is ready to operate in either single sideband or CW mode. For CW, you can now use a code key to transmit. We set CW mode. It will switch to transmit and then back to receive mode based on the setting of the Vox delay control. For single sideband mode, we attach a microphone, then select either upper or lower sideband and either press to talk or Vox mode. For press to talk mode, you should set the speaker to the ALC position and adjust the mic CW level so that speaking into the microphone it peaks at about S3. The press to talk button on the mic selects whether to transmit or receive. Testing 1, 2, 3. For Vox mode or voice operated transmit, the mic CW level is adjusted fully counterclockwise and talking into the mic will activate transmit. Initially, the Vox sensitivity, anti-trip, and Vox delay controls need to be adjusted once for your microphone as described in the manual. The transmitter is only intended for up to 50% duty cycle with no more than 30 seconds of continuous transmitting in CW mode at full power. This can be a consideration if transmitting in digital modes, as they may require turning down the transmit power. When I was in high school, in the back of the electronics shop there was a ham radio station. The previous electronics teacher had been a ham, but the current one was not, and it was left unused. It had an HW-101 with all the accessories, including the timer, clock, and a Cantana dummy load. I had my ham radio license, and along with some other students, we got it running, at least for receive. We didn't manage to set up a working antenna for transmit. Getting an HW-101 brought back memories of that radio. Overall, I would say the major strengths of the radio are it's a proven, reliable design, it's well documented by Heathkit and others, Virtually all parts are still available new or surplus. It can be repaired and aligned with minimal test equipment. It offers the basic features of a CW and single sideband transceiver with adequate sensitivity and selectivity and decent output power. And it has a classic vintage look that doesn't overwhelm the operator with displays and menus. As a design that's more than 45 years old, by today's standards it does have a number of weaknesses and missing features. It's large and heavy, it requires an external power supply and speaker, and it doesn't support some of the current HF bands. The receiver has poorer specs than modern rigs with digital synthesis and DSPs. The transmitter is lacking support for RIT or dual VFOs. The dial only provides an approximate indication of the operating frequency. And more adjustments are needed during operation, for example the 3 controls to readjust tuning and loading when changing frequency. Theoretically, it can be used mobile, i.e. in a vehicle. This requires the mobile power supply. In practice, I think you would need a car of 1970s vintage to fit the transceiver, power supply, and other equipment needed. There are many common modifications that people have made to improve the radio. I've kept mine stock except for the official Heathkit design changes. Some owners have, for example, added digital dials or replaced the VFO with a modern DDS design. There's a product called the X-Lock which stabilizes the VFO. The Hot Water 101 was a great value in the 1970s when compared to commercially built units, and Heathkit sold more of them than any other amateur radio transceiver. Hundreds, if not thousands, are still on the air today. There's something about using a classic radio with lots of knobs to turn and tubes that light up and warm the room. I hope you enjoyed this video on a classic piece of amateur radio gear. If you did, check out my other YouTube videos on classic radio and test equipment.